Our topic for today is about mole and molar mass of elements and compounds. Atoms and molecules are minute particles, but the mole concept allows us to count these particles and establish a standard for reaction stoichiometry. It also explains the properties of gases, provides a universally accepted standard for mass, and helps us to distinguish between elements and compounds. We use special names for counting units. For example, pair for 2, dozen for 12, gross for 144, and ream for 500. In chemistry, the atomic counting unit is the mole, which comes from a Latin word that means heap or huge pile. Mole is the amount of a substance that contains as many particles as there are atoms in 12 grams of carbon-12. Therefore, the mass of 1 mole of any element contains the same number of atoms particles as there are in exactly 12 grams of carbon-12. The mole is given the SI symbol mol and is equivalent to Avogadro's number 6.022 times 10 to the 23rd. The number that 1 mole represents is expressed as 1 mole is equal to 6.022 times 10 to the 23rd particles. Such particles could be atoms for elements, molecules for covalent compounds, formula units for ionic compounds, or ions for charged substances. Mole is a very fundamental unit in chemistry. As in physics and mathematics, we need to measure and count things. We cannot simply put any amount of carbon dioxide in a calcium hydroxide solution in a flask and produce some solid calcium carbonate, since the result depends on the mole ratio between carbon dioxide and calcium carbonate. Thus, we need to weigh and measure the volume of substances in order to know the amount of products that can be produced, if any. All chemical equations show the mole ratio of reactants and products. The concept of mole allows us to determine the molecular mass and the formula of a substance if its mass is known. Many chemical and physical properties, volume of gas, the molarity of a solution, even the pressure of a sealed tank, are all related to the concept of mole. 1 mole of a certain element implies 2 things. First, the atomic mass expressed in grams is different for each element. This mass is known as molar mass of the element. Molar mass of the element is equal to the atomic mass expressed in gram per mole of the element. And second, is that Avogadro's number of atoms is the same for all elements. That is, 1 mole of carbon is equal to 12.0 gram, that is equal to 6.022 times 10 to the 23rd atoms. Or 1 mole of oxygen is equal to 16 grams, that is equal to 6.022 times 10 to the 23rd atoms. Or 1 mole of sodium is equal to 22.99 grams, that is equal to 6.022 times 10 to the 23rd atoms. This means that 1 mole of any element is equal to 6.022 times 10 to the 23rd atoms. The formula mass or molecular mass of a compound is determined from the atomic mass in grams and the number of atoms of each element as indicated by the chemical formula. The formula mass is expressed in gram per mole. The mass of 1 mole is referred to as the molar mass of the compound. The molar masses of various compounds differ, but the number of molecules or formula units per 1 mole of substance remains constant. Percent composition expresses the mass of each component element per 100 mass units of compound. That is, percent composition is equal to the mass of component element over mass or molar mass of compound times 100. Percent composition allows us to know the ideal dosage or amount of substances to use. In medicine, for example, using more than the recommended dosage of a certain substance may adversely affect one's health, as in drug overdose. In the same manner, materials may also be damaged if applied or used with substances in excess. Conversely, using less than the recommended percent composition may not give the desired effect on one's health or materials. That ends our discussion for today. Thank you for watching.